Hello, welcome to this O&DR Modurol video. This is video MT08 in our series of XK8 videos detailing how we converted our automatic XK8 to manual transmission. I'm going to split this video down into three sections. First of all, a bit of introduction and tell you where we are at this point in the project. Then we'll look at the process of setting up the clutch, working out the spec of the items, and then we'll look a little bit about the design principles of the mechanism of the clutch pedal itself. Okay, so first of all, where we are now. So the manual transmission kit, as it were, that I bought was a second-hand kit from Tom Lenthal's car number 2. He was one of the guys who originally did the manual transmission conversions, and there are some bits missing. The main piece, or the most difficult to source piece, is actually the pedal box conversion, so I've decided to try and address that first, because obviously if that's not feasible I might as well stop. So this is where we are at the moment. I've got a sort of semi-working pedal box with a clutch pedal and a master cylinder. I've learned a lot to get to this point, but also there's a lot of questions on my mind. I'm not quite sure I've nailed it. I'm not quite sure this is good enough for the reasons I'll come into as we go along through the video. If you've got any advice, if you design one of these yourself, I'd appreciate some help and input. So when you're designing the clutch pedal system for your manual conversion, you first need to start with a clutch. So in this conversion, a clutch didn't come with the car, but I was able to track down the clutch that was originally used. I believe it was this McLeod RST 6713-07. It's a twin disc organic clutch was used. So I bought one of those because I know it'll work. It actually fits the custom flywheel I've got, so tick in the box. I've got one component. With the kit there was a throwout bearing. This is actually the method of releasing the clutch. Obviously this bearing acts on the clutch fingers and releases the clutch. But unfortunately when I've actually measured this, it didn't seem quite right. Then what I've done is I've actually, through reverse engineering, looking at other cars and actually taking some advice, I bought a Wilwood 3/4 inch or 90mm master cylinder to act on this. However, when I look at, I did some measurements of the throwout bearing. You'll see the measurements here, and it only seemed to get 15mm of travel, which equates to, with the piston in there, to get 15mm of travel I needed 11 cubic centimeters of fluid movement or displacement from the master cylinder, which again started to ring alarm bells. When I look at the clutch spec of the McLeod clutch, actually what I was told is you need a maximum air gap setting of 6.35mm. I'll show the measurements here, or 6.35mm or 1/4 of an inch, and the full disengagement about 11mm or 7/16, which when added up you need a maximum displacement of 17.5mm or 11/16 of an inch, although you can actually get away with 14mm at the lower end, albeit I'm not quite sure why there's such a 3mm discrepancy. This isn't really my thing. But anyway, I'm thinking I need to aim for the maximum. I need to have a throwout bearing that's capable of at least 17mm, and that only gives me 15 and quite a big fluid displacement. When I actually looked at other throwout bearings, I thought maybe it's best to stick with McLeod, buy a release bearing off those guys, because at least they will then be able to confirm that that release bearing will release the clutch. So I believe I need a 1400 release bearing, but unfortunately I'm not able to get the spec, the cylinder diameters, to confirm how much fluid I need to put in there in that throwout bearing to give me my 17mm travel, believe it or not. What I was able to, I asked McLeod again what sort of fluid displacement I needed to release the throwout, or to release the clutch through a 1400 throwout bearing. So when I actually asked McLeod what sort of master cylinder I needed, or what sort of stroke I needed off a 0.75 inch or 19mm master cylinder, and they came back with this answer, which was anywhere between 28mm and 35.6mm of stroke, or 0.11 of an inch to 0.14 of an inch. So in theory this cylinder might just do the job, but I'm not sure why I quoted both figures. I'm an engineer, I'm always a bit cautious. I want to have a specification that covers all options. So I'm thinking, I need to find a cylinder with 36mm of travel. Then I looked at what I'd actually bought previously, and I actually bought a Willwood master cylinder, the correct one apparently. It was listed as a 1.4 inch travel, or 35.6mm travel, but apparently it wasn't. I'm not quite sure how this works, but you can advertise something on eBay and not actually deliver what you advertise. When I actually measured it, I'm getting roughly 28 to 30mm travel on this cylinder. When I queried it from the seller, he was saying, "Oh no, we don't sell those cylinders anymore. We only sell ones that do 31.8mm travel, or 1.25 inch." I said, "Well, it's not even doing that." So I'm really not sure what to do with this. It's a bit of a muddle. So I was thinking I was quite safe with my Willwood cylinder, but apparently there's lots of doubt. So I started looking at cylinder specs in general. You can see here some rough calculations. So originally I was thinking at the top there that my 0.75 inch master cylinder was with a 35.6mm travel, or 1.4 inch travel, was going to give me 10 cubic centimeters of displacement at full stroke, which would have been great. That would have been the maximum 10 cc's that I'd heard I needed. But then when I find out, when I calculated if I have a reduced stroke down to 31.8, and bear in mind I'm not getting 31.8, it's down to 9 cubic centimeters, so it's getting a bit towards the bottom end of the spec. So I was thinking, maybe I ought to just uprate the cylinder a little bit, go for a 7/8 cylinder, or a 22mm cylinder. And you can see, even with 28mm stroke, which seems to be quite achievable, I'm getting 10.8 cubic centimeters of displacement. So that's pretty much in the spec I'm looking for. But bigger diameter cylinder you get, the more clutch pressure I'm going to need to displace, or the same amount of fluid. So I'm basically going to get a harder pedal. So I want to stick with a 0.75, but I'm not sure I really need to upgrade to the 22mm or the 7/8 cylinder. Anyway, so that's where we are at the minute. I'm a bit unsure where to go. So let's park that for a moment, and we'll look at actually the mechanical side and how I've designed that. And in being how important that clutch, the master cylinder stroke is. So I've designed this system around what I thought was a 35.6 or 1.4 inch stroke travel, and it wasn't quite working out why, and guess why it doesn't work? Because I'm not getting the stroke. Anyway, complaint over. So section 3, designing the mechanism. So as I say, I started off sort of reverse engineering. I found some photographs of a previous similar application, started throwing some CAD dimensions on that, and then what I did, I drew up as best as I possibly could the cylinder and the pedal box, and started to play around with the alignment of the master cylinder to the pedal box. I thought originally to start having the master cylinder vertical in line with the hinge point of the brake pedal, but unfortunately, as you'll see in this short video here, it's quite tight on right-hand drive cars. It's different on left-hand drive, which we spoke about in the previous video. You can see it actually touches, the clearance is very tight, it touches the master cylinder if it's located vertically. So I decided to shelve that idea, and I'd actually tip the master cylinder forward in car slightly to give greater clearance to the wiper mechanism. I could start deflecting the wiper arm to clear it, but I didn't really want to go down that route. I'm modifying enough on this car. I didn't really want to get into modifying wiper arms. And then what I've done is I've just imposed an arrow on the master cylinder there showing what I thought was the stroke length I was working with. I then measured the existing brake pedal position to the pedal box, because my theory is that the clutch pedal is going to be basically the same position in the car, albeit to the side, as the brake pedal. Obviously the accelerator sits slightly further forward in car, but the clutch and the brake pedal are almost should be on the same level, I believe. So I measured where the brake pedal was, put that on my drawing. Typically, when I've researched on the internet, people are saying use a 12-inch pedal length. It'll give you good leverage. Obviously, it depends on your link to your master cylinder, but 12 inches is roughly what you should be working with. So I basically struck an arc from where I thought the clutch pedal was going to start. I also worked out, using the brake pedal again, the maximum travel to the bulkhead. So given how much angle of deflection we were working with, so I've put that on there, you can see that. Then I've worked out the angle, which I believe was about 29 degrees with the 12-inch pedal, and it's about 150 millimeters or 6 inches from the brake pedal to the bulkhead roughly. Then I've actually, here's an interesting bit, obviously I've designed with a tilted master cylinder, you've got a flat plate with where it's mounted. Now I've then struck a line from that point directly down, because that'll be how you want your hinge point being in the middle of your master cylinder stroke, if you would. So it minimises the lateral movement of the piston arm, or to the cylinder, if you would. I hope that makes sense. So then I've double checked. I've added the 29 degrees movement onto the link between the theoretical hinge point and the master cylinder, and made sure, I said, that it's got that parallel plane is going through the middle of it. You see there, so you've got your 29 degrees of your pedal transferred to 29 degrees of the link, deflection of the link to to the master cylinder and then making sure that is in the middle of that stroke. So you can see there, once you've got your hinge point and where you think you're going to master cylinder is going to be, you can start adding bracketry for the hinge point, as I showed there. A bit of a close-up. There you go. And then you can start, or I've actually designed the clutch pedal from that to the theoretical brake position, and I've knocked one out, and I've done this a couple of times and refined it. And that's basically what I've got. You'll see I've got basically the principle I've used for manufacturing these is laser cutting and press brake and MIG welding the lower bracket. You can see, hopefully you can see that the stroke is quite critical to the link length and what have you. So I'm going to have to go and revisit this with a reduced stroke of 28 millimeters, which is going to move everything slightly. So I've got very close here, but there's no prizes. I've got to go back and revisit everything. Hopefully that explains how I've gone about designing and the theory between my pedal, how I've made my pedal box. I'll go into more detail once I'm sure what I'm talking about, if you would. I'm going to knock another one of these out with the correct stroke for this cylinder. Hopefully it'll look a bit better. You might see here, I've cut a bit out here. There are lots of constraints, and in the next video I'm going to show you how I put this in the car and the problems involved with that. It's quite tricky, to be honest, and a lot more involved than I thought, but not impossible. Anyway, that's what I'm going to cover in the next video, to enlighten anybody who thinks the mechanical side of this is easy. I keep hearing that. Mechanical side of this project is easy. It's the CAN bus things that are a problem. I know CAN bus is a problem, but this pedal box is a real nightmare. Well, not nightmare, it's quite tricky. Anyway, I digress. Hope you find that interesting. If you're considering doing this, I'm hoping if you watch these videos, you'll learn from my mistakes, and it'll be a little bit easier for you doing it. Anyway, thank you very much for watching. Please like, comment, share, and subscribe for more XK8 videos. Bye bye.